lesson 6.5, starting with trinomials. This is something we did do in Unit 5, so most of this should be a review. None of these are the harder ones that require the box method. Okay. So we always want to start with looking for a what? GCF. Make a note on your paper on every single time you factor. You need to make a note and check for the GCF. This one does not have one that is correct. So just put none there.
I've been lost this whole unit.
All right. GCF means something they all three have in common, and they don't have anything. Does anybody remember back on Unit 5 how we factored this?
Didn't we like combine the like terms or whatever?
We would combine like terms if there were any, but there's not any. We look for two numbers that multiply to be your C value, which is negative 24. And those same two numbers add to be your B value, which is 2. So try to figure up those two numbers. Don't call them out. Take a second. Look in your calculator. Play with numbers in your calculator to figure out what two numbers multiply to be negative 24 and add to be positive 2. Caden, what are those two numbers?
6 and negative 4.
Positive 6 and negative 4. And if we want to check to see if he's correct, if I do 6 times negative 4, I get negative 24. And if I do 6 plus negative 4, I get 2. You have to be able to figure out these numbers. They're not somewhere on your paper. You have to know your multiplication tables, really.
How do you draw that little symbol in the middle? Make an 8 and then put a slash.
That go line this way and then loop around and up.
Okay.
All right, so that's just an and sign. You can put whatever you use for and. So what I do with these two numbers is put them in parentheses, x plus 6 and x minus 4. And that's all we have to do for the factoring part. Now, if we want to check the answer, store some random number for x. There's already a number stored in your calculator, most likely. Yeah. So x squared plus 2x minus 24. And then my answer, x plus 6, x minus 4. See if those match. Do they match? Mm-hmm. Yep, so I did it correctly. That 39 means nothing. Don't put that on your paper. But if they match, it's correct. Questions on that? All right, number 32. Let's check for a GCF. Is there one?
No.
Are you sure?
There's one.
They all have an X. So your GCF is X. That's it. Because this one doesn't, neither of these have a number in front. So there can't be a number with the X. So when you have a GCF, that goes in the front. And so I'm going to take an X out of each of these. I'm dividing by X. So when I divide this one by X, what am I left with? You don't just have a random floating exponent. X squared, or X to the second power, plus X. So this one I had X squared, and I divided, or I took out an X. So I had an X left over. And this one, minus 20. Good. So we took out the x from each of those terms. And now we can look for two numbers that multiply to be negative 20, and those same two numbers add to be what? 1. Not x, 1. So you need to play around with some numbers in your calculator and find two numbers that multiply to be negative 20 and add to be positive 1.
Well, I don't even know. Oh, well, yeah, dude.
Who wants to give me those numbers? Logan?
5 and negative 4.
Positive 5 and negative 4. Let's check to see if he's correct. 5 times negative 4. Is that negative 20? Yep. 5 plus negative 4. Is that 1? Yep. So those are your two numbers. Your GCF has to be a part of your answer. And then we have x plus 5, x minus 4. Are there any questions?
These are a lot of steps for these.
All right, number 33. Let's look for a GCF. It is 2x. All three of these numbers are divisible by 2, and they all have at least one x. So 2x. So we're going to write that on the outside, our GCF. When I have 2x cubed and I divide that by 2x, what's left over? X to the second power. 2 divided by 2 is 1, which you don't need to write a 1 in front of a variable. And then I had x cubed, so that's 3 of them, and I canceled out or divided out 1. So I was left with x squared. Plus, what's 38 divided by 2? 19. And then I had x squared, and I took one of the x's out. So what's left over? X plus, what's 68 divided by 2?
34.
34. Do I have an x with this one? No, because I started out with just one x, and I took that single x out. So now we need two numbers that multiply to be 34 and add to be 19. See if you can figure those two numbers out. Who thinks that you have it? McKinley? 17 and 2. Seventeen times 2 is 34. 17 plus 2 is 19. So we write the GCF down, and then x plus 17, x plus 2. Are there any questions on number 33? Number 34, is there a GCF?
Yes.
Yep, what is it?
2x.
2x. Okay. All three of these numbers are divisible by 2, and all three of them have at least an x. So when I write my GCF on the outside, what is this first term left with?
X to the second.
Plus,
22x.
nope, 11x.
Oh.
22 divided by 2 is 11. And then I had x squared, and I divided out one of the x's. Plus 30. Because 60 divided by 2 is 30. And then that x got brought out. So we need two numbers that multiply to be 30 and add to be 11. Yes.
5 and 6.
5 and 6. Good. So GCF needs to be brought down. And then we also have x plus 5 and x plus 6. If you put the 6 first and then the 5, that's totally okay. But your GCF does need to be written in the very front. Are there any questions on number 34? Number 35. Look for a GCF first. Is there a GCF?
No.
No. What's different about number 35?
There's no x on the last one.
No, that's not really what I'm looking for.
Oh, okay. 9 perfect score.
That doesn't matter. That matters if we're doing difference of squares. What else is different?
Honestly, I don't know. Oh, we have it's not a cubic, it's a...
We're not looking to see if it's perfect cubes or perfect squares. We have an x to the 4th and an x to the 2nd. All of the other ones, this is an x squared, and this one is just an x. So when that's the case, when you have an exponent of 4 and then a 2, the only change that you need to make in these problems is that when you're doing your parentheses, you put x squareds here instead of just x. So you have to be paying attention to your problem and paying attention to those exponents.
So if there's 4 in the front, I'll put x squared.
If this is a 4 and that's a 2.
So it has to be a 4 and
a 4 and a 2. Yep, it would be this combination. If this was a 4 and this one was just an x, it wouldn't factor like this at all. That wouldn't work. So we need two numbers that multiply to be 15 and add to be 8. Don't call those two numbers out when you get them. But see if you can figure them out yourself. Who has them?
Oh. Wow.
I was going to call on somebody, but thank you. They are 5 and 3. Now, I didn't have a GCF, so there's nothing to go in front. What do I put in my parentheses? X squared plus 5 and x squared plus 3. Good. Number 36. Look for a GCF. Is there anything that they all three have in common? No. So we need two numbers that multiply to be 28 and add to be negative 11. See if you can come up with them. Luke, you got them?
Yeah, -7 and -4.
-7 and -4. So in my parentheses, I put x squared minus 7 and x squared minus 4. Look at this one right here. Do you notice anything special about that one?
It's got negatives.
It's got a negative specific.
Make it simple.
What?
You can just make it like x minus 2.
Close. You can't just make it x minus 2. This is a difference of squares. So we can make it x plus 2, x minus 2. We're not going to do that right now. We will get to some examples later where when we factor, we can factor something again. So this one is technically a difference of squares, but we're not going to worry with that just yet.
I was close.
You were close. All right. And then the very last method of factoring, so we started with GCF, we moved to difference of squares, some difference of cubes, and then we did the trinomials. Oops.
Wait. Are we doing 4 terms?
Yeah. This last method that we're going to do is grouping. Okay. And grouping is done when we have 4 terms. And there's some steps to follow. They're written right out. We're going to go through an example. So as long as you can follow some steps, it won't be so bad. Step 1 says to group the first 2 terms together and the last 2 terms together. So these first 2 terms are going to be in one group, x cubed plus x squared. And then these 2 terms, negative 4x minus 4. Step 2 says to factor the GCF of each group. So I'm just going to look at one side at a time. So just right here.
At this time, I need junior boys.
So what is the GCF of x cubed and x squared? It's what? X squared. They both have x squared in common. Now when I take out the x squared, what's left? This one has an x.
Any senior boys?
What's left over here? Not nothing. 1. When you divide by x squared, you get a plus 1. Now let's look at this side. What is the GCF of this side? It has to be negative 4. Look at your first term. If your first term is negative, your GCF has to be negative. If you don't do that, it won't work out correctly. So when you divide negative 4x by negative 4, what's left? 1x, or just x. What is negative 4 divided by -4. 1, so plus 1. If you have done it correctly, what you have in parentheses will be exactly the same. Is that the case? Yes. So you did it correct. So your outsides goes in one set of parentheses. So this becomes x squared minus 4. That's one of your factors. X squared minus 4. Your other factor is what you had in parentheses, x plus 1. But you only do that one time. You don't need to write that twice. If I go to my original problem, x cubed plus x squared minus 4x, oh my gosh, x cubed plus x squared minus 4x minus 4, I get 360. That number's not important, but it should be the same when I type in my answer. And it is. So we did it correctly. So we've got 4 examples to do. Number 25. Oh, my numbering got way off. Yeah, I went from 36 to 25. That's fine. All right, so we're going to follow those steps. So group the first 2 terms together. X cubed minus x squared. And your last 2 terms. 9x minus 9. What is the GCF of this side? X squared, leaving what? X minus 1. Good. What is the GCF of this side? 9, leaving what? Minus 1. Does anybody not know how I got anything from this line? So the final answer that we write is x squared plus 9, x minus 1. Because our outside numbers go there, and then what we have left in the parentheses go there. And again, if they don't match perfectly, the signs have to be the same. Everything has to be the same. You messed up somewhere, so you go back and check your work. Are there any questions? Let's do the next one. We put x cubed plus 5x squared together and negative x minus 5 together. What is the GCF of the first set? X squared. And what's left over? X plus 5. What's the GCF over here? What's the GCF over here? They don't really have anything in common, but we can't leave it blank. So if something really doesn't have a GCF, we would put 1. But what do I need to put? Negative 1. Because this starts with a negative, we're going to put negative 1. So if I divide this first one by negative 1, what's left? A positive, because negative divided by negative is a positive. x. Negative 5 divided by negative 1 is positive 5. Do our insides match?
Yes.
Yep, so it's correct. And so what goes in parentheses? X squared minus 1. And what about the other one? X plus 5. Perfect. Are there any questions? If there's something in this that you don't know where it came from, you need to speak up and ask. All right, next one, number 27. No. Not always. All right, first two terms. 4x cubed minus 5x squared. And then we have a negative 16x plus 20. What is the GCF of this first set? X squared. It's just a coincidence. It's not always x squared the very first time. What's left? 4x, because that one had the 4 that didn't get divided out. X minus 5. What about the GCF on this side? Negative 4. Because 16 and 20 are both divisible. They're divisible by 2, but they're also divisible by 4. And we want the bigger number. Plus, it needs to be negative.
Can you technically skip the second step and just find the GCF and then fill in the parentheses?
Skip over here.
Yeah, because you'll know they'll be the same.
Well, you don't need to do that because you could have messed up here or somewhere. And this is kind of a way to check yourself by doing this side right here. To double check to make sure you did it correctly. So if I take, we know it should be 4x minus 5, but what if you messed up here? What if you forgot a GCF on this side? Like what if there was supposed to be a 2 in front of the x squared and you missed that? If you missed that, then your parentheses wouldn't have matched. So don't just skip. So what is negative 16x divided by negative 4? 4 x. And then 20 divided by negative 4? Negative 5. All right, I want you to try number 28 on your own.
Probably.
All right. This is what you should have gotten on number 28. The first side, you should factor out a 2x to the 4th, leaving you with x minus 9. And then you should have factored out a 7, leaving you with x minus 9. So your final answer is 2x to the 4th plus 7, and then x minus 9. Any questions on that? All right, turn the page. We're not going to work out any more examples, but we're going to fill in this kind of cheat sheet, I guess. So this is just going to have like all of the formulas that we did all on one page. Whenever you're factoring, doesn't matter if it says to factor, your first step should always be the same. And what is that first step? Check for a GCF. That's very important. It will change the entire problem and the way that you solve it, possibly if there's a GCF. Usually it makes it a lot easier to figure out.
If you don't do a GCF, will it come out
No.
Well, sometimes it won't be factorable if you don't take out the GCF. But yeah, if it is and you don't take out the GCF and you type it in the calculator to check, it will still show as the same answer, but it won't be completely factored, so it wouldn't be counted correct. All right. Now, once you've checked for a GCF, your next step is to look at how many terms there are. If there are 2 terms, that means we're going to use one of these 3 methods that we learned in this lesson. The first one is difference of squares. So when you're doing difference of squares, that's when you have a subtraction sign. That's important. It has to be subtraction. And you have 2 perfect squares. Does anybody remember this formula off the top of your head? It's A plus B, A minus B. And to get your A and B, you take the square root of both sides. There is not an option for a sum of squares. So if you have like x squared plus 4, you couldn't do anything with that. It wouldn't work. But the cubes, we do have a sum and a difference of cubes. How do we find the A and B on these? Cube root. So you take the cube root. And these were the ones that had the longer formulas. So a sum of cubes starts with A plus B. And then it's A squared minus AB plus B squared. The difference of cubes is almost the same. Oops. It's A minus B, and then A squared plus AB plus B squared. So this is all if it's 2 terms. You'll do one of these 3. And if I don't tell you factor by difference of squares, you have to look at the numbers and figure out if they're perfect squares or if they're perfect cubes. And you just look at the list. Perfect squares list, perfect cubes list to see which list they're on. Then we get to trinomials when there are 3 terms. Now we didn't do it where there was a number in the front of A. We didn't do any of those. So you won't have those. But when we have trinomials, you are looking for 2 numbers that multiply to your C and add to B. 2 numbers that multiply to C and add to B. And then you'll just have your parentheses x plus something, or it could be the x squareds, like we did a few of those examples. So your answer would look like one of those 2. You're getting your exercise today. All right. If there are 4 terms, your only option is grouping. So we want to group the first and second terms, and then the third and fourth terms. That's what we do first. Sorry, I know that's hard to see because it's... trying to help you. Then you do GCF, insides must match. And then remember, in your answer, you have your insides in one parenthesis, outsides in another parentheses. That's all of the factoring that we did, and we'll stop there.